This may come as a surprise to, well, nobody, but I'm quite a sci-fi nerd. I grew up with Star Trek, Star Wars, Doctor Who, Douglas Adams, Warhammer 40k, etc., all of whom included alien civilizations as a fundamental part of their universe. As such, it's something that I would love to discover as definitely real, as it would make our reality so much more interesting and exciting. Unfortunately, we've been looking at the stars for quite a while now, in every way we currently can, and so far everything we've seen seems to be entirely natural, nothing that might have been done by some sort of alien intelligence. With the sheer scale of it all and our current mastery of science and technology, it's impossible for us to actually go out and in any reasonable time frame and take a direct look. Forget travel time, it would take more than 4 years just to send a single message back from our closest star neighbor. So we're left with asking the basic question: is there actually nobody out there, or can we just not see them? Some very clever people pointed out that logic and mathematics could, if not answer the question, then at least organize the way we think about it. The clever people started messing around with some formula, and a key point was reached: the Drake equation. The most common version looks like this. In simple summary, it's a formula that attempts to start with the maximum possible number of points that could lead to intelligent life, and then estimate the filters that whittle that number down. I didn't entirely understand it at first until I climbed a little more into it, so let's take a quick dig through the elements. N is the answer, the intended result. It's the number of civilizations that we, probabilistically speaking, should be able to see signs of. In essence, if n is greater than 1, then there should be signs of intelligent life. The bigger the number, the more obvious it should probably be. If it's less than 1, then it's more likely that we're alone, at least for a meaningful distance. R asterisk is the average rate of star formation in our galaxy. I originally thought this would just be the number of stars that there are in the galaxy, but it's a surprisingly dynamic place. Stars die and are born all the time, so we need to take that into account to get the full starting total of possibilities. We used to think it was a lot less, but it's currently estimated at 1.5 to 3 new stars per year. Fp is the fraction of those stars that have planets. Also originally thought to be a much lower number, but we now understand that it's actually a common part of the formation of stars, the rule rather than the exception. Ne is the average number of planets that can potentially support life per star that has planets. Now this is where the complexity and uncertainty really comes in, because the processes of abiogenesis, the first formation of life, is still filled with questions, like what elements are required? Do you need nearby planets like Jupiter to prevent something like meteor bombardment? Do you need a big moon to make tidal pools? So far we've only been able to look at one single instance of life having started, namely here on Earth, so data is limited. Fl is the fraction of the planets that could support life that actually develop life at some point. The more we learn about abiogenesis, the more it seems to be inevitable. Chemical reactions just happen. The ones that are sustained are well sustained, and as long as there's a lot of energy and resources, things get more complex. Unfortunately, probability in cases like this is very difficult, because there could always be a single variable that we're just missing that could drastically change the result. Fi is the fraction of planets with life that go on to develop intelligent life. Yet again, is this inevitable? Is evolution always going to discover how better intelligence makes better survivors? There are other very smart species scattered around our planet. Did we just get to our level first? Would they have become like us if we weren't around? Fc is the fraction of civilizations that develop a technology that release detectable signs of their existence into space. Now this does seem inevitable, as light and radio and other radiation forms are excellent ways of communicating and understanding the world. On the other hand, the better we are at communications technology, the less noise we make. We currently trap a huge amount of our communications in fiber cables underground, for example. We use more efficient radios to talk just as far as we need to. Of course, we're also deliberately being noisy, sending messages out into space, but maybe in a few decades we'll completely stop that. And L is the length of time for which such civilizations release detectable signals into space. Remember that cosmically speaking, we've only been looking for a very short time, which defines our cone of visibility. Could we have just missed signs of a civilization that went silent? Could there be one that's about to appear? There are other variations on the equation which add or change certain variables, but the answer does seem to fluctuate back and forth rather than being definitively one side or the other. The initial variables by Drake's team were considered to be quite conservative, and yet his results for n were positive, ranging from 20 to 50,000. But lengthy criticisms of some of the assumptions by other researchers have pulled it into the negative as time went on, while others pushed it even more positive. However, it's important to remember that this is more about asking questions to make people think about it rather than actually finding a definitive answer in itself. The usual goal of such thought experiments, really, is to begin preparing for possible scenarios. It's better to say, think about how to talk to aliens and finally discover that there aren't any, than it is to not think about it and be utterly unprepared if some arrive. But our path to interesting thought experiments often comes through making some reasonable assumptions, so that we actually have a tentative road forwards. So let's assume that, as seems likely, n is a positive number and there are intelligent species out there that we should be seeing, and yet we don't. And this is, in essence, the famous Fermi paradox. The first possible answer to the paradox is obvious. Our assumptions and variables are invalid, intelligent life is really hard to get going, and humanity is a rare or actually unique specimen. However, as an unhelpful answer to the question, we're stepping past that. We're contemplating some more useful scenarios that themselves range from positive to very negative, in order to have something that we can actually act upon. Let's look at a couple of the examples along the range. Scenario 1, a very positive scenario, is that there's a better way to communicate that we just haven't discovered yet. When we do, maybe we'll be greeted by a galactic civilization with open arms or similar appendages. For that scenario, we should spend more time preparing our first interactions, figuring out how to best interact peacefully with alien minds. Scenario 2 is that the alien minds have decided that we're not ready, and are therefore deliberately hiding their presence from us until we are deemed ready. This is a popular scenario amongst more spiritually minded ufologists. The only thing we can really do there is just keep getting better, I guess. Scenario 3 isn't positive at all, other than the possibility that we can overcome it. The question is there another inevitable test coming that all intelligences face? Perhaps something like the risk of destroying ourselves through nuclear war, or pollution, or yet another civilization-ending meteor. Our history is a chain of extinction events, so perhaps our future has a few more for us. The preparation here is obvious. We need to spend time and resources on taking care of ourselves. On the far end of the gradient is the scary scenario. Is there something out there that is aggressively stopping us? Is there perhaps an older alien civilization that doesn't want to share the galaxy? So the moment we trigger its sensors, it will come to destroy us. Or perhaps there's some sort of galactic war that we're about to roll into. We need to prepare ourselves for the worst, perhaps doing things like being a little quieter and just listen to space rather than shout into it. Is preparing for all these possibilities actually quite useful? The answer to that is a firm yes. It motivates us to keep looking outwards, to learning about our reality so that we can best deal with whatever comes. And it also helps us look at ourselves, to contemplate our own actions with the possibility that outsiders might judge us. Either way, I hope you found this as interesting as I do. Please drop your thoughts in the comments. Like if you liked the video, subscribe if you'd like to see more, and I hope to see you next time.